Today our focus is on IQR rule of thumb, and we will also look at mean absolute deviation, or we'll often refer to that as MAD. So first, IQR rule of thumb. IQR rule of thumb is basically a way of determining when I have a series of numbers, what are my boundaries from which values within the numbers would not be classified as outliers. Another way of asking that or stating that is, what are my boundaries so that I know which numbers are outliers? It's always going to start with a set of data, so we have our set of data. Your first step is going to be find your quartile 1, quartile 3, and IQR. This is no different than finding IQR. So we want to have the IQR. So I break my data in half, right? No. I first need to have it in numerical order. So we have 3, 10, 11, 14, 14, 15, 23. Now comes the question we're looking for. If we're finding out outliers, we're trying to determine, is the 3 an outlier or is the 23 an outlier? Because everything else would be between those two values. Now, in order to find the quartile 1, we need to first know the median. I have 1, 2, 3, 4, 5, 6, 7 terms. 7 divided by 2 is equal to 3.5, so I need 3 terms on one side of the median, 3 terms on another side of the median, and my median's going to fall in the middle. Well, that's 3 terms, and my median would fall in the middle. Now we're looking for the medians of both of those so that we end up with a Q3 and a Q1. And now our IQR is 15 minus 10, which equals 5. Now that we've determined what the IQR is, we are now going to multiply the IQR by 1.5. So we multiply 5 times 1.5, and that's going to equal 7.5. 7.5 is going to be the value we use to adjust our Q1 and Q3 to determine if there are outliers. So, step 3. Subtract the 1.5 times IQR. Now, in this particular problem, the 1.5 times the IQR of 5 gave us 7.5. So that's the value that we are going to subtract from Q1. So 10 minus 7.5 is 2.5. We are also going to add the 1.5 times IQR. Well, our 1.5 times IQR, again, we said was 7.5. We're going to add that to Q3. So Q3 was 15 plus 7.5. Now, anything outside these boundaries, from 2.5 to 22.5 is going to be an outlier. Now, I use range. Range is commonly referred to as these values. I'm going to change this to boundaries. And the reason why I'm doing that is because I don't want you to get confused when we're talking about IQR range versus variation range. So we're just going to call it boundaries. The boundaries are from 2.5 to 22.5. So are there any outliers? Well, 3 falls within that range, so it's not an outlier. 11, 14, 14, 15, 10, they all fall within that range. But notice, 23 is larger than 22. So on our number line, 2.5 is somewhere right down here. 22.5 is right about here. 23 then falls outside of the boundaries. It is an outlier. Now, this is a good example of a problem where it is beneficial to determine mathematically what the outliers are, because 3 probably looked like a low outlier to the same degree that 23 looked like a high outlier. But we wouldn't know for sure without calculating it. Now, during this course, at least on quizzes and tests, the solutions will be much more obvious. They will either be obvious that it's an outlier or obvious that there is no outlier. You're not going to be required to utilize the rule for identifying outliers on your test or quiz. Your turn. Use the IQR rule of thumb to solve. Suppose you have a data point of 82 in a group of data that has a first quartile of 89 and a third quartile of 94. You'll notice that the IQR is 5, so is the data point 8.2 an outlier? Pause the video and come back and check your solution. Now, if we're dealing with the values Q1 as 89 and Q3 as 94, then that means that we're looking for the Q1 minus my 1.5 times IQR. Well, 1.5 times 5 is 7.5. And so we end up with 89 minus 7.5, which gives us a value of 81.5. That is my lower boundary for which numbers are classified as not an outlier. So if it's greater than 81.5, it's good. 82 is greater than 81.5, so it is not an outlier. All right, now let's take the same set of data and figure out the MAD, or the mean absolute deviation. There are a few processes and there are different ways this looks, and I will give you a guided set of notes instructions that go along with mean absolute deviation. But I generally recommend that students first calculate the mean. So 23 plus 10 plus 15 plus 14 plus 14 plus 11 plus 3. And all of that adds up to 90 divided by 1, 2, 3, 4, 5, 6, 7 terms. Remember, you're showing me how you calculate the mean, because that is one of the 7th grade standards, is that I can tell that you can calculate mean. If you ended up using your calculator and did not get up to 90, you're going to get a wrong answer for mean, but may actually know how to calculate mean. So the mean is 12.86. All right. We have a nice fun decimal that we're going to work with, but that's okay. Now, for calculating mean absolute deviation, I highly recommend that you take all of these numbers that are written horizontally and write them vertically. So 23, 10, 15, 14, 14, 11, and 3. And the reason why you're going to write them vertically is because you are going to subtract the mean from each one of these terms. So minus 12.86. And if you do it in chart form like this so that you know you're subtracting 12.86 from each one of these values, I can just put a line here now and go ahead and give my equals. So 23 minus 12.86 gives me 14.14. 10 minus 12.86 gives me a negative 2.86. 15 minus 12.86 gives me a positive 2.14. Lost my decimal there. 14 minus 12.86. Yep, gives me a 1.14. Well, we have another one of those. 11 minus 12.86 gives me a negative 1.86. 3 minus 12.86 gives me a negative 9.86. All right, so let's talk about what steps we've done. Step 1, we calculated the average. Step 2, we subtracted the mean from each original data point. Now to step 3. It is mean, which we've already done, and we've dealt with the mean. Deviation, we talked about meant change. That was subtraction. Now we need to look at absolute. Absolute is where we take the absolute value of the change. So absolute value means all of these we're looking for their positive distance. That means anything that's negative becomes positive. Now, at this point, we calculate the mean again. But now we're using data set 2. And our data set 2 is all of these absolute values that we just created. So 14.14 plus 2.86 plus 2.14 plus 1.14 plus 1.14 plus 1.86 plus 9.86. And all of that added together gives me 33.14. We had 7 numbers before. We're still going to have 7 numbers, so we will now divide by 7. And we get a mean absolute deviation value of approximately 4.73. That is the process for mean absolute deviation. 4 steps. Average. Subtract the average from each original data. Take the absolute value of all those solutions. Find the mean of your new data set. And we have a mean absolute deviation of 4.73. Now, just like range and IQR, mean absolute deviation is a measure of variation. This particular type of variation is telling us the variation around the mean. Now, that's a lot more specific. Notice when we talked about range. Range was variation from beginning to end. IQR, we have a beginning and end, but now we're looking at the middle 50%. Remember, we're talking about the box. So the middle 50%, Q3 to Q1. Now that we're into mean, we are focused much more on where the mean is, and we're looking at individual changes around the mean. So as we get to the various levels of variation, our focus is getting much more intense. That's mean absolute deviation.